Hello, everybody. Thank you all very much for joining this webinar today. My name is Leon Vergeer and I'm the General Secretary of G3-PLC Alliance. I assume that everybody attending this webinar today is familiar with G3-PLC, so I will not give an introduction to G3-PLC or the Alliance. I just want to tell you that we are doing very well. The number of members of the Alliance keeps growing. We are now at nearly 100 members. We have over 400 G3-PLC certified devices, and we have over 50 million G3-PLC devices, more than 30 countries worldwide. And that keeps growing. If you follow the G3-PLC Alliance on LinkedIn, you can regularly see new implementations from all over the world, not only in smart metering, but also in smart lighting, EV charging, smart railway stations, and other applications. We organized last year a webinar about setting up and maintaining G3-PLC networks in October last year, and that webinar was very well appreciated, and quite a lot of people attended that webinar. And after the webinar, we received several questions about type of measurements to be done and about cleaning up after rollout of G3-PLC meters. So therefore, we thought it would be a good idea to pay attention to that specifically, and therefore we organized this webinar today. And thank you again for joining today. So the objective of this webinar is to share experiences from DSOs, specifically about the cleanup process after the rollout. And 3 DSOs will describe a few typical cleanup examples from their own experience. They will describe if they are using filters and provide some information on that and share the lessons learned. We will try to answer your questions today in this webinar during the presentations. And maybe the attendees can also share some experiences from their own. If you have any questions during the webinar, please, you can post them under questions on the right in the control box. And after the webinar, we will share all the presentations with all the people attending. So that's a little bit about the topics. I'm very glad that smart meter experts from Enedis in France, EVN in Austria, and ST in Latvia are willing to share their experience with us today. They will each make a short presentation of about 10 minutes. And we have to make sure that we have some time left at the end to answer any other questions or have a short discussion. And before each start their presentations, the presenters will briefly introduce themselves, I think. So next to these 3 DSOs presenting, we have joining today attendees from several other DSOs in Europe, Africa, and the Middle East. As you can see on this slide here, all these DSOs are working with G3-PLC at the moment or are planning to do so. And additionally, we have a few other members of the G3-PLC Alliance joining in this webinar who are actively involved in training for G3-PLC or cleaning processes for DSOs, including companies like, for example, Siemens from Austria, Trialog from France, Arcosa in Spain, and IES and ACN from Switzerland, if I'm not mistaken. So that's about the agenda. That's about the people in the webinar today. So I'd say let's delay not anymore and turn to the first presentation. So Thibault and Remy from Enedis, may I ask you to start and give the first presentation?
Yes, thank you very much. Good morning, everyone. My name is Thibault Mollier. I was a manager of a supervision team. I spent 3 years managing this team. So we had a great experience about monitoring and cleanup after rollouts. And today I am with Remy Dubel, which is
I'm PLC expert at Enedis Lab. I work on Linky qualification process and on level 3 diagnosis on PLC problems on the field.
So today we're gonna talk about our experience, and we're gonna start with the presentation of Enedis. Enedis is a French DSO. We operate 95% of the territory in France. We are the main DSO in France, and we have a rollout of Linky meters. This is a specific smart meters, G3-PLC smart meters, and we reach around 90% of the rollout today. We have on the field 30 million meters. And the rollout should be completed by the end of this year. You can see on the next slide the IMI architecture. If you go on the next slide, Leon, please. Yeah, thank you. You can see a brief introduction of the Linky advanced monitoring, advanced metering infrastructure. Yes, so we have a specific Linky information system. It's not MDMS or HES that you can find on the market. We designed this IMI. It is custom made by Enedis, and all the DCU communicates with mobile network. So it's a UTMS or LTE communication. We have in average 50 meters per DCU, and the biggest cluster we have reach 1,200 meters. So it's a quite big, important cluster, and it works fine. So now let's talk about problem solving on PLC networks. We have 2 steps. The first one is monitoring and analysis. We have several supervision teams which analyze and try to solve issues remotely. They don't have to go on the field, but they have more options. And if needed, they can request an intervention. And so the second step is on-field intervention. You need to get your hands dirty, and if the PLC issue is very specific, we ask for a PLC technician to investigate with advanced tools. So on the next slide, you can see a Linky SUP, which is a dedicated tool to detect and treat incidents. Most of the incidents can be treated automatically by the software. You can run actions like firmware updates, reboots, meter kicks. And the objective is to provide to the supervisor all the information to investigate. For example, the cartography, customer informations, meter status, etc. From this software, you can send the case to the good service. And for this case, you can send it to the PLC technicians.
All right, Leon, if you can go on the next slide. So the second part is the on-field intervention. Again, and we have for the on-field intervention about 60 local technicians for the whole French territory. There is around 1 or 2 persons in each regional office, but they are all working part-time on this activity. The technicians are identified within the Enedis workforce, originally not specialized in telecommunication. They are mainly customer or network or metering technicians. It's a career opportunity for them to be trained on the PLC. So the training is in-house. We have a 3-day training for all the PLC technician, where they learn theory and practical about PLC. They are practice on experimental network to learn how to search and find the noises. The training starts short after the rollout in 2016. It was a little bit early because technician had time to forget. So the main advice is to do it as close as possible for the operation of the first issue on your system. Can you go up on the next slide, Leon, please, on the tool case? So all the technicians are equipped with a tool case that we designed. It's equipped with 2 tools that are available on the market, an oscilloscope that allows us to make spectrum measurements, and a PLC sniffer. We choose the Nbox tool from Neuroncoms. They are both needed to measure and analyze PLC communications. The picoscope is more used to make instantaneous measures, to measure the noise, to find it. And the sniffer is used to capture and understand the traffic, allowing in-depth analysis and studies and application. And to complete this tool case, we have a tablet that allows the technician to manage the intervention and to see the measurements directly on the screen. All right, now that we see how we are organized, Thibaut will start to present you a first case study to give you information.
So the first case was in Évry, which is a city near Paris. In the same neighborhood, we had 7 substations with low performances. And so we decided to go on the field because everything was fine with the DCU, the situation was great. So we tried to investigate on this neighborhood. So on the next slide, you can see the cartography of one of the substations. It's a collective housing. Évry is a big city with big buildings. And we checked all the informations on the GIS, and we found a lot of boiler room for collective heating. So it was the first clue for us, because we try to find big customer that can interfere with the PLC. And so we went on the field. On the next slide, we first started with the substation. We start the measure, or we always start the measure with the DCU and to find the nose signature. Here you can see it's a powerful nose, almost at the same power than the PLC. So the DCU was not able to communicate with one meter. So then we go closer and closer. We try to find the origin of the nose. And so we went to the boiler room, and we can see then that the nose was more powerful. So the next thing to do is to find the technician of the boiler room and try to disconnect it to confirm that the perturbation of the nose was the boiler room. And so the nose disappeared, and we tried to discuss with them, and we found out that the company disconnected the low pass filter behind the frequency variator. So we asked them to reconnect it in all the neighborhood, and so the performances went up. And so here it's important for us to say that for the filters, we don't give them the filters. We just ask them to disconnect, to replace, or to filter the equipment if necessary. We don't pay them for that, so we need to be convincing with the customer, because if they don't want to filter the nose or to remove the equipment, we can't do anything else. And so the next case study will be given to you by Rémi.
Well, on this second case study, well, the methodology to find the noise is quite the same as the previous one. So we first do the measure in the substation, where we can identify low power noise. Then we have two feeders. We had search noise on the two feeders. So to find that the noise is locally in a school that has solar panels, I think. So we perform a measure on the second feeder too. And the solution on this case is not to remove the noise or to deal with the school administration, but more about our system, because the solution is to increase the number of PLC meter on the network. Here in this case, we had some older meters that were not replaced, so we changed them to improve the saturation of the network, and the performance went up. Actually, we have a lot of cases where if we only install the meters on the field, we solve a noise problem, because the meters we have are a good noise immunity level. We ensure that we have good meters with laboratory tests, and we have a minimum immunity level to reach to buy the meters from the manufacturer. So just simply with the deployment, and we increase the saturation and we improve our performances. Well, thank you for listening to us, and if you have questions, we will take them at the end, I think.
Sorry, I made a mistake here. Rémi, I had just a short question to you still. I understand in the last example, yes, the problem was caused by a solar panel, but you didn't have to install any filters there, correct?
Yes, correct. We just put more meters, replace meters, older meters.
Okay.
We don't need any filter for this installation.
One of the questions we received, Rémi, is can you elaborate a little bit on your objectives in Enedis, on the target KPIs in terms of readings and reachability and how you got there?
Well, our main KPI is the number of meters for which one we have an index. We read daily index on each meter, and this is the main KPI. So our system is built to gather as much as possible of the consumption index each day. Most of the time, the index is read on the meter during the night, where we have lower problem of noises on PLC. But there is several retries during the day, so it's important to build your system around your KPIs. We also perform different services on the meters, such as contract configuration and so on. We also have KPIs on these operation, but the SLA is up to 24 hours, so we have sometimes to have a retry operation on the communication chain.
And currently you are able to reach the targets in your rollout?
Yes, we have good performances. We have 98% of matches read each day, and the remote operation are also have a good KPIs.
Okay, thank you. If there are any other questions, please share them with the control box. But in the meantime, I think move to the second presentations from EVN in Austria. So Wolfgang and Nicole, can I ask you to briefly introduce yourself and explain and share your experiences?
Yes, my name is Wolfgang Rehner. I'm head of the metering department in the DSO of EVN. It's Netz Niederösterreich. And
yeah, hello, my name is Nicole Huberei. I'm the team leader of the operation center, Smart Meter, and I'm in the company since about 13 years.
Okay. Leon, can we start? Yes, what is EVN? Our main mother company is located in Lower Austria. It's around Vienna, but we are working in 6 countries. But our main focus is Austria, where we have also network, electricity, gas, heat, hydropower, wind power, photovoltaics, and so on. And we speak about the rollout in Lower Austria. Yes. Can you go to the next slide, please, Leon?
Yeah.
We have around 800,000 meters, which we have to replace with smart meters. Our goal is, there's a legal requirement in Austria until end of 2022 to change 95% of all meters to a smart meter. And our rollout plan is orientated to this to reach the goal. Before we started with the rollout, we had a very long time testing phase for the system and software suppliers, so that we can be sure that everything is working fine. We've started last year on the 1st of September with the rollout, and this Monday we have installed 126,000 meters. We change, in the moment we change around 10,000 meters per week. One thing is maybe a little bit specific for Europe. We don't use the standard A band. We use the FCC band in the frequency range from 150 until 480 kilohertz. Next slide, please. On our web portal, every customer can see what is the status of the rollout, when will be his region, when we will start there, and so on. And we have different colors. If it's dark green, then the rollout has finished. But it's going very well. Next slide, please. What is our smart meter infrastructure? Our central systems, the head-end system and the MDM system, will come from Sargent-Com. We have two different meter vendors, it's Sargent and Piper. The leading system is our billing system, the SAP system, and we think that we can reach with minimum 95% of the meters with PLC, and for a small amount of meters we also plan to install a point-to-point meter infrastructure. The customer can see on the web portal every day his consumption from the day before. And we have, in the past, we had to make yearly billing with smart meter. We will change, if the customer wants this, to monthly billing. Okay, next slide.
Okay, so for you we have three examples prepared, and before we will tell to you, we want to explain what devices we are using in EVN. For the measurements, we use the PLT M1503 device with a notebook to evaluate the results. And what training does our technicians got? We have 23 service centers where we have one technician in the field. And they got 1 day of basic training about the procedure of PLC measurement, about organizational stuff, documentation, and so on. They also got a short training during the handover of the equipment. So how to use the PLT measurement device and how to see the results on the notebook. And then the technicians go to the field alone, but they always receive support remotely from the operation center team. And for bigger measurements in the field, we have 3 experts in our department, which also support the colleagues in the field. When we go to the next slide, we have our first example. Normally, before we're beginning with the examples, we have 3 basic steps. The first step is that we compare the noise level in the field on different points. It depends how the disruption is analyzed. The second step is where the noise source is at the highest point. We start to switching off the customer to locate the noise source. And the third step is that we are going in the customer's house and then switching off the circuits and really locate the noise. So, for example, a set receiver or another device. For our first example, you can see it in this picture. We have 26 meters on 1 low voltage branch where we cannot reach the meters. You see the red points. When we go to the next slide, you see 1 to 7. These are the points where the technician have done a PLC measurement with the PLT device. So they started at point 1, make some other points, compare the noise level. On the next slide, you can see the results. So these are the results from the PLT measurement device. And the colleagues decide that on the point number 7, so the picture number 7, is the highest and the characteristic which they think the noise source will be. And in this point, on the next slide, we can see it. On this point, they started to switch off the customers, and they located 1 house with a SAT receiver, which has disturbed the completely branch, low voltage branch. That was our first example. When we go to the next slide, we have another example, also in the same area, but on another substation. There we only reached, we don't reach 1 meter. And the procedure is nearly the same. The technician also measured with the PLT device in the grid. And they found a noise 2 blocks beside this meter. And here you can see a picture of the noise source. And on the next slide, yeah, you can see that the technician has installed a PLC socket filter. And on the next day, we see that the meter was reachable again. So the third example we have for you is nearly the same like the first one. We cannot reach a completely low voltage branch. You can see the blue and red points in the picture. We have done 2 measurements on the red marked positions. And when you go to the next slide, we also see that the noise source was at the beginning of this branch. We are again going into the customer's house, switching off the circuits and detect 2 interferences. This was electronic and a WLAN router. And we installed 2 PLC socket filter also in this house. And on the next day, the completely branch was really reachable again. When you go to the next slide. Yeah. Here is an overview about the filter we will use and using in the field. We have 3 different PLC filters, but at the moment we only have installed the PLC socket filter. We will install the top head rail filter in the next weeks, but we don't have experience now with these filters. How we deal with the customers. So normally, when the customer device disturbs our PLC network, so we have issues to reach meters, we will install a PLC filter, but always the better way is to uninstall the device which disturbed the PLC network. But that is not so easy to handle it with the customer. Our assumption, and you see it on the slide, is based that defective devices, which would also damage other devices in the household in the long term. So this is a good argument to explain it to the customer. In the case if the customer has issues because of our PLC grid or the smart meter installation, normally we don't install a meter. We always ask the customer how often he has issues, does the device has a CE mark and so on, but that is not our, how to say it. We can reach the meter, but the customer has an issue, so normally the customer has a defective device in his house. Yeah. Yes, next slide, please. What are our lessons learned at the moment? And we are still at the beginning, I'm pretty sure. It's always the best if the rollout finished up to 95 or 100%. Because we see it also in this picture, we had a short friendly customer rollout last year in March. We only installed 1 meter in the building. This meter was not reachable. So we think there was a noise inside the building. After we started the rollout in August or September, they installed 20 other meters in the same building, and all 21 meters were reachable without doing nothing in this building. So we see if we install more meters, we can reach it. Yeah. When we go to the next slide. Yeah. Our second lesson learned is that the PLC organization needs very long time in our case. For example, in those 2 pictures, you see 1 village, and we just do nothing for 6 weeks to see how the grid will organize it. We have a village with more than 1 DC, so 1 and more substation, and always if you have more DCs, there is a lot of cross-talking. Yeah, and this can you see, I think, in the next slide. If you go further. Yeah, here you can see this cross-talking. You see one village in the middle where we have orange and red points. And we can see a lot of smaller villages around, which everything is green. So if we have a village with only one data concentrator, normally everything is reachable and we have not so much troubles. If we have a village or an area with more DCs, we have a lot of cross-talking and also a topic with this PLC organization. And here we need more experience, and we are also working together with Sargencom to learn. Okay, the next slide. Yeah, we are pretty sure that now it's very important to learn with the experience we will earn also in the next months and years. And as I said it before, we think that defective devices or devices without CE mark are often the cause of issues in the PLC grid. And I think we are the last slide. So thank you for your attention.
Yeah, thank you very much, Nicole. Can you say again how far are you now in your rollout? You mentioned, I think you had to roll out to install 800,000 meters, but how far are you at the moment?
At the moment, so with Monday we have installed 126,000. I think today we are 130,000 meters.
Okay.
We install around 2,000 meters per day at the moment.
Yeah. Wolfgang, one of the questions we received is about outsourcing, externalizing the cleanup process, and clearly in EVN, I think you chose to do it internally, but other DSOs, I think even in Austria, they don't do it themselves. Can you tell a little bit how you look at that different approach?
For us, make it no sense to make outsourcing because it is not finished with end of the rollout. I think during the life cycle of this system, every time we will get disturbances in the grid, we get maybe new devices and so on. And on one side, we need the data on daily basis, and we can react very quickly when the operation center make in the morning the check which meter where we have problems, maybe area or anything else, and the technician can go on field on the same day because they are in the area. And one of the big advantages is also for us because when we have 800,000 customers and around we have 23 service centers, the colleagues know very well the grid, where they are responsible. Sometimes they know a part of the customer, so it's much more easier if foreigner go to the customer, say we have to measure here and so on. So our experience is the customer trusts us, and it's especially in this time with Corona, we install meters in all the time during the lockdown. There's no problems because there's a good relationship between the customer and us.
Okay, thank you, Wolfgang, for your view on that. I received a question, Thibaut. Maybe you can answer that. I think it's related to your rollout in France. So you mentioned you had good KPIs, high readout, but how do you treat the meters which are not able to communicate due to noise on a daily basis? Do you send meter readers to get the billing data, or how do you deal with those meters?
Yeah, so we have a procedure for this case. We try to have less than 0.5% of meters without communication in the last 2 months. This is one of the KPI. And for those that reach these 2 months, we try to operate remotely. And if we can't have the index, we try to call the customer, or we try to go on the field to check the meter. And if needed, we replace the meter if we think it's not a PLC issue. We have an algorithm that can say if it is a probability of hardware issue for this meter. So if we don't have data for a long time, we call the customer, and if we don't have answers, we send letters to have at least one index in the last year. We try to have at least one index per year.
Yeah, for the annual billing, of course.
Yeah, for billing, yes.
Okay. And before we go to the next presentation from ST, Remy, one specific question for you. So you mentioned the Enedis PLC toolbox, but can you explain what is the purpose of the N-box tool, and why is it combined with a Pico spectrum analyzer?
Well, these two tools has a quite different role. The picoscope only do spectrum measurements, and the N-box allows us to see the traffic, to see the G3-PLC frames on the network. Why is it important? The measurement that you will do with the picoscope is just a view at one point of the network. For example, in the substation, you have a really local view, small view, and the G3-PLC traffic embeds a whole lot of information. If you are familiar with the protocol, there is the LQI information that are embedded in messages, in some messages, and with these information on the PLC traffic, you can gather information on the whole network. So with one measure at one point at the substation, you will be able to have a view of your substation, your DCU, but also a lot of meters that are around your DCU. So you with other information, where you link your short address MAC with your meter ID, you will be able to see if some meters are in the noise, or if some meters are good communication, have good communication. And the N-box tool allows you to see a whole lot of information about the noise around the DCU, and not only at the place that you do your measurement. So this is interesting for us because it makes diagnosis faster, because with one measurement you have lots of information on the network.
Okay, thank you. I hope that answered the question. Remy, another question since you're on the microphone. From your experience, once a group of meter behind one DC is able to be read, and maybe directly or maybe after a cleanup action, can it happen, or does it happen that later in time new issues appear on the same group?
Yes,
What's
of
your
course.
experience?
If a noisy equipment is installed, or maybe well, we saw on urban area some equipment that are switched off during a certain period of time and then switched on again.
Yeah.
We can think about heaters, water heaters, but well, it's Paris example, but there is for example, a critical equipment has two feeders from two different substation, and it's switched regularly from one DCU to another. Well, not one DCU, one feeder to another, and it's make noise alternatively on one network and then the other, and then the first one and extra. So yes, you PLC is changing. There is a lot of change on the PLC network, so it's not because you went once time on the field that you will not have to go again.
No, I understand. Thank you. Then let's move on to the third presentation. Vilis, can you please explain and share your experiences with PLC meters and the cleanup required?
Yes, of course. ST are DSO in Latvia. So yeah, I introduce with myself. I'm Willis. I'm a senior smart meter engineer. I'm responsible for meter troubleshooting. So, and about our smart meter rollout plan. So till 2022 year, plan install 1,096,000 of meters. So far installed are 79% smart meters, and for this year our execution plan is 1 million meters on the field. Also our target in network is 80% of PLC meters and 20% of GPRS meters. At the moment, we have 24% of GPRS meters. We understand that PLC meters is not so good solution for us because it's not so cost effective as we want, and also cleaning process is expensive for point-to-point meters. Please, next slide.
Sorry, Vilis, you said GPRS is not the best solution for you, and you prefer PLC, right?
Yeah.
All right.
Yeah, because it's expensive. We need to pay for each SIM card. So yeah, it's not so cost effective. There is architecture our network. So we have 4 vendors smart meters. So it's for ADAX. ADAX we use prime meters in Cenelec A band. There's 100,000. So L gamma is GPRS meters. Also about 100,000 hexing also are GPRS meters. And for G3-PLC meters, we use sensing meters. As you see, we use also some GPRS meters, but it's only for cases where on substation we have 1 or 2 meters. So there we install this GPRS meters, or meter are very far from substation, let's say 1 kilometer or 2. So for that case, we use GPRS meters.
And your current rollout is involving these 4 different types of meters at the same time?
No, ADAX meters was started in 2014, then in 15 Algama, in 16 hexing meters was installing, and now we roll out with Sanxing G3-PLC meters.
Ah, okay. Okay, I see. Yeah.
Please, next slide. There is also explain about 2 examples, most common cases. First, most common cases is disturbances from frequency converters in pumps where are installed in heat plant and water stations. So in these cases, these converters are used without filters. So because it's cheaper, but when we identify this disturbances, we install filters because clients don't want to install filters. So that's solution in this case. So second case is disturbances from telecommunication providers, so power supply blocks, and actually telecommunication suppliers so replace these blocks themselves. So we just need to identify where is this issues, and everything's go fine with that.
Mm-hmm.
Please, next slide. And for troubleshooting, if all substations are unreachable, so at first we measure noise in substation, so to see how noise looks like. Then we check nearest distribution boxes, so where we can see noise and can identify directly house from where disturbance is coming. And then third step is identify client. So for troubleshooting, we use MFR 500. It's a spectrum indicator. And for most interesting cases where we can find issues, we use Neuron toolbox sniffer. Well, please, the next slide. And also there is a picture of spectrum indicator MFR 500, so where we can see a house looks like disturbances. In left side was disturbances, and so in right side you see disturbances with filter, and we can read meters in these cases. Next slide. So our troubleshooting team is 1 director, so then is system architect, 2 system engineers who are responsible for MDM and FES, so 2 system engineers who are responsible for security, and 1 DevOps engineer who developing new programs. So I tell you later about this. And then is for troubleshooting is 2 smart meter senior engineers and 10 smart meter engineers. This is field engineers, so they go on field and identify problems. So next slide. How we get better about training. So we was trainings with Slamet. So it's actually this company not only sells equipment, but also get good trainings and say new tips how to find disturbances in network. Then also was trainings from Neuron, Trialog, and most important is our work experience. So when we change with our work experience and learn from what we have discovered and what we should do better. Next slide. For filters, we use G3-PLC. This is Emicon filters. And also we have discovered that in some cases also help capacitors. So we just install capacitor and that is enough for disturbance. Oh, thank you. Next slide. And what we have learned that we use analytics to solve problems remotely. So we have designed our program. It's called Monta. So where we can check our KPIs. Also, we can check failed devices when we see network if some DCU doesn't work. So we can get information from these systems and also can check reachability of devices. And also we use GIS. It's system where we can see meters on the map, so we can identify meters which aren't reachable. And also there was one case when we saw that 1 meter is unreachable, and see there is also telecommunication provider there, and just called them and told please change power supply blocks, and they change, and we see that meter starts read. So yeah, thank you.
Okay, thank you.
Slide. Yeah, any questions?
Well, I got so I saw, Vilis, that you had different trainings from different companies for the PLC, and I also received a question about the content of the training given at Enedis regarding the troubleshooting in PLC. Because of the time, I don't think we can go into details of that, but maybe I can share kind of a content or topics covered in these different types of training to provide to the participants of this webinar and to inform them about the content of the different trainings. So I will address that after the webinar and share some information on that.
Yeah, of course.
So I think we covered most of the questions we got. And looking at the time, unfortunately, it's already an hour past. So if you have any further questions for me in general or for any of the presenters, please contact us, let us know, and we will try to answer your question as good as we can. One thing to conclude is I would like to understand if this kind of information sharing is useful to you. And if this is useful, then we can maybe organize future sessions to share experiences on the same area or related topics. So when you leave the webinar, there will be a short survey, and one question is about topics you would like us to address in the next session. So please be clear. If it's not useful, just please answer no further questions, no further topics to be covered. But if there are any other topics you would like us to address, please be as specific as you can, and then we can see if we can organize a future session and address these topics. So I want to end by thanking all of you very much for joining today. I hope it was interesting to you, and I want to say a big thank you to all the people presenting today. It always takes more time than you think to prepare a presentation, but I think it's very much appreciated by all of us. So thank you very much. I hope we will meet again soon in a webinar online, or hopefully face-to-face end of the year, maybe when we have the European Utility Week again, hopefully in Milan. So hope to see you there again. And like I said, I will share with you all the presentations with everybody participating. And please, if you have any questions, don't hesitate to contact the presenters or me to answer your questions. So thank you very much, and hope to see you again soon.